Why is Australia so neglectful of its engineers? This is a story about one such engineer, Arthur Bishop, engineer, designer, and inventor of automotive and aircraft steering systems. Arthur Bishop's grandfather, Joseph Bishop, was a coach builder. One uncle, also Joseph, edited Australia's foremost coach and motor bodybuilding magazine. Another, an uncle, Albert, was one of Australia's early body designers. And yet another, Joe, ran West's Wheelworks, a manufacturing works and machine shop. Obviously, Arthur was destined for something in the automotive industry. But I'll return to the question, why is Australia so neglectful of its engineers? Because Arthur Bishop, the name, is not well known. And earlier we saw a list of inventions, rural inventions from the Geelong area. And perhaps they're better known than some of these people who are more recent. Men like Robert Handley Brown, who invented radar, David Warren, the black box flight recorder, Fiona Wood, spray on skin for burns victims, John O'Sullivan, Wi-Fi, Ian Fraser, Cervix and Gardasil vaccines, Jim Sullivan, deep focus camera lens, Mark Lidwell and Edward Booth, the pacemaker, Arthur James Arnott, the electric drill, Graham Clark, the cochlear implant, Henry Sutton, an early automobile designer. Now, while he hasn't got the credit, but he certainly was an early developer of TV and the telephone. Born in Sydney in 1917, Arthur Bishop was a gifted engineer, successfully lodging over 100 automotive and aeronautical patents. He was thrust into designing aircraft landing gear early in World War II, when the Beaufort bomber landing gear collapsed regularly on Pacific Island and outback dirt strips. An additional problem was the rear tailwheel shimmied, often that severe that the torpedoes the planes carried fell off before they got off the airstrip, which was kind of disastrous. Australia built 700 Beaufort bombers and 365 Beaufighters. Thus, it was essential and urgent that the problem be fixed. It's also interesting to note that the Australians abandoned the Bristol Loris engines and instead used the American Wasp engine. That was also built in Fisherman's Bend, along with the wings and the tailplanes of not only the Beaufort bomber, but a number of other aircraft. The rest of the plane was largely built at CAC and GAF, which were next door, and then the whole thing was assembled in the hangar in Sydney. Bristol, the plane's original manufacturer, had no time to fix problems. Their factory had been bombed and Australia was a long way away, and when the Australians started to build the plane, they discovered the plans were flawed, and the company did not take Australia's problems seriously. I guess they had enough problems of their own. Arthur Bishop found himself co-opted into the Department of Aircraft Production at the Beaufort hangar in Sydney, not only to redesign the undercarriages, but to build a drop test rig to prove the design. The rig was required to measure the stress, de-acceleration and acceleration, while simulating a 12 foot per second descent rate and a 26,000 pounds of thrust when the plane touched down. So a complicated issue. The rig proved superior to the one used by Bristol and more efficient than the one used in the US. Bishop's rig recorded readings every 250th of a second. The British rig recorded every 25th of a second, and after 18 months of development at an American university, that machine recorded every 50th of a second. Bishop's solution for solving the shimmy was transferred onto the Lancaster bomber and other aircraft, including the Douglas A-26 bomber nose wheel. Bishop, however, found the British engineers were reluctant to admit his solution was superior to theirs. His biography records that Bishop faced men who were wrenchingly arrogant, blinkered and self-satisfied. Bishop was commented to his biographer, "What makes it difficult here is that you just never find young chaps in good positions." The adoption of these Australian inventions was more than a technological achievement, and a tribute to Australian ingenuity is also a story that swells with human frailty, frustration and nerve. These were quotes by his biographer. It was a different story in America. Bishop arrived at Wright Field, Dayton, Ohio, to see his damper in action on a Douglas A-26 bomber on a specifically prepared runway with corrugations that mimic the Coral Island airstrips. So these airstrips were rough, and the problem with the nose wheel was the old supermarket trolley shimmy made it very difficult to handle the plane. So after the Americans heard about Bishop's success with the tail wheels on Beaufort bombers and Lancasters, they asked him to design one for their aircraft. So he sent and that's a photograph of one and the patent for it. He sent one off from Australia and then got on an aeroplane, went to England and then went to America. So he arrived at Dayton Field to see the last test of his device. And when he arrived, the colonel that was in charge of the project decided that he had some doubts about the tests to which had illuminated the shimmy. He came to the conclusion that there was no shimmy, so maybe there wasn't a fault at all. So he asked them to take the damper off the aeroplane, which they did. He took the pilot's seat only to find the plane was uncontrollable at 50 miles an hour. The big problem was not only did he have to abort the takeoff, that the shakes were that bad, they loosened all the photography and equipment, measuring equipment from the plane, and it was smashed up. So it was a little bit of an expensive exercise. However, the Americans were very happy, and all A-26 bombers were fitted with Bishop's damper. This was really a saving grace for Bishop, because he was almost on his last couple of dollars when he got to America. And the success and the sale of the damper to the Americans put his company on the map. While at Wright Field, he'd noticed when he landed on the field in a B-29 bomber that the pilot had, regardless of having a steering wheel and being able to operate the front wheel, he used the plane's thrust, engine thrust and brakes to steer it because the steering was that heavy. So Bishop thought what he needs is power steering. And so he set about, excuse me, I'll need a bit of, he set about designing a power steering for the B-29 bomber. Went down the shop and bought a kid's maths set with a compass, a ruler and a set square, and under the light of Porky's hot dog stand, he drew up a variable ratio power steering for the B-29 bomber. Bishop saw the potential of his variable ratio power steering for motor cars, and a meeting while he was in America with John DeLorean saw his steering developed for a 1957 Packard. However, Packard was not travelling too well under Studebaker, and so the steering system never got into a production vehicle. Getting his steering accepted by other American manufacturers who already had their own designs was a goal too far. In 1959, however, a revised VR steering was finally fitted to a production car, the Mark 10 Jaguar. And you can see there the middle photo shows the steering that the wavy steering that it is developed for Packard, which is kind of a strange looking thing, but it worked. It would, however, take to October 1971 before his variable ratio system was fitted to a General Motors product, the Holden Statesman DeVille, as standard equipment, and it was also optional on other models. Ford Australia followed in March 72, making it standard on the Fairlane 500 and optional on other Falcon models. Getting his variable ratio steering into a Holden meant, however, he had to drop a lawsuit that he'd started with GM over a patent infringement. Bendix in America had lent on Bishop's design, and they were installing Bendix power steering units in some GM makes, and Bishop sued them. But they were dragging it out and probably would have broken him if he hadn't have pulled the plug and gone with Holden without the lawsuit hanging over his head. Later on, a further innovation developed with General Motors in 1980 was a new forging process for producing steering shafts for steering racks, one that was first used in the GM J car, or as we know it in Australia, the Chimera. To my surprise, I learnt that over 16 million J cars were produced between 1981 and 2005. They were produced as Vauxhalls, Opels, Pontiacs, Chevs, Buicks, Oldsmobiles, Cadillacs, and even under licence by Toyota. It's a rather remarkable achievement, and as a car platform, it ranks number 5 in the world. In my first presentation, I talked about the first generation and the last generation of the Monaro. This is the second generation, a HQ, and one that is also fitted with Bishop's variable ratio power steering. This and 2 other vehicles in my fleet have Bishop steering. Of interest is the inset image, which shows the steering box cover, and it has on it Kirby Bishop branding. This is a second type of cover. The first one, it had Bishop Kirby branded on the box. I believe this is the only time a GM product had the designer's name on a part. I'd like to be proved incorrect or correct. The left-hand picture is an exploded view of the HQ style steering. Bishop Technology Proprietary Limited did not manufacture their steering systems, but rather licensed others. In Australia, this was Bendix, who used machines designed by Bishop and made by James Kirby. James Kirby actually owned Bendix. High-pressure valve machines were also installed in Ford America, made by James Kirby, and they turned out over 2 million valves that were fitted to most Fords with power steering in that early period. In recent times, the Bishop Variatronic power steering speed sensitive unit provided high levels of feel and low effort in parking. In 2008, their active rack system won the Innovation of the Year award, which is a global award. These images show the Mercedes-Benz steering division, which was fitting Bishop designed steerings to almost all of their cars. Arthur Bishop believed in patent registration, and his company worked consistently using the Patent Cooperation Treaty to enforce strict compliance. So in other words, while he designed his steering systems, he never actually made any. They were all made by other people. The other thing that Bishop did was that in the early days, any profits he made were turned back into R&D. And this then furthered further patents and further licensing fees. So the company really expanded because of the efforts they put into R&D. Bishop Steering Technology today is owned by SVB. I'm not going to try and pronounce the name, but it's not a manufacturing company in the true sense. They're actually a steel forging company. They make blanks and forgings for steel, and they saw, I guess they saw Bishop Steering Technology as a source for more forgings. So Bishop Steering Technology exists in Sydney today, but they're held by a German company. The interesting thing is that today SVB in Germany produce or license steering systems for 23% of the world's automobiles. The company now holds 350 steering patents. Arthur Bishop is known to few Australians and even less elsewhere, yet his steering systems designs are commonplace. And I guess that most people will have owned a car, perhaps at some stage, that had a Bishop design steering system in it. Jim Longworth at the 2013 Engineering Heritage Conference said that engineering inventiveness and business success are not necessarily linked. Bishop has shown this is not the case. His legacy will continue. Arthur Bishop's story is uplifting and shows true grit and Aussie ingenuity. It is told by Claire Brown in her biography, Driven by Ideas, and it's well worth a read. I thank the Bishop family for their images and SVB for Germany for some help. Questions?
We have Hugh online is interested in asking questions.
And I should say, Hugh, thank you for commenting, Hugh. Hugh has an interest in steering. He was one of Holden's chassis engineers.
Am I on, Norm?
Are we frozen? Just hang on.
Am I on, Norm?
Sorry, Hugh. If we just dropped out for a second there, Hugh. So if you could repeat your question or comment.
Okay.
You might not.
I think
be muted.
I think you're on mute, Hugh, or maybe your microphone's not turned on.
I thought I'd unmuted myself.
Yeah, it looks like your audio's on. Hugh, can you write something in the chat maybe? And we could if you go into the chat and write your comment or question there, because it sounds like your microphone's not connecting up. You're not muted, so something going on with your microphone. Or you could go into your device settings and make sure your microphone's connected.
Well,
which is in more and then device
settings
settings at the top.
Got my speakers on full. Can you hear me now?
Yes. Yes, Hugh, we can hear you now. Yep. Yep, go for it. Hugh, are you there? Hello, Hugh. See my device settings. Make sure this. Hello, Hugh. You there? Well, it's good this happened at the end. What was that, sorry? Speaker to what? That? Is that okay? Hello, Hugh. Can you hear me? Hello. Can anyone hear me?
I'm,
Yes,
I'm
Lou,
sorry,
yeah, I can hear you.
can't get through.
Hugh, we can hear you.
I can hear you. I can hear Hugh as well.
Okay, Hugh. Do you want to ask a question, Hugh?
Coming and going over here.
Might be dropping out in and out. It seems like there might be a delay or something on it.
Tell him to ring me.
Yeah.
We can do it by this technology.
Yeah. Um, so the speaker, so the real text and microphone.
Yes, Norm, I hear you.
We can hear you now, Hugh. Go for it.
Coming out loud enough?
Yes.
Okay. The comment is simply this. I knew Arthur Bishop personally very well. As you previously said, I was one of the chassis engineers. I was a chassis engineer in 1974 to 1978. And in that time, I got to know Arthur Bishop very well. And we worked together on the HQ station variable ratio recirculating ball system. Arthur was an absolute genius, no question about it. But his main interest, and always was in the manufacturing processes of, in other words, the tooling, the machinery that actually made the steering components. The design of the steering itself, the steering box and the geometry and so forth, was incidental. But they ran in parallel, obviously.
Yeah.
The one thing I remember very clearly, he wanted to make the HQ station steering sharper and more responsive than what finally turned out to be. He wanted the steering wheel to rotate no more than 2 turns. And I finally convinced him that there'd be a small fraction of the driving population that would be able to handle a big car like the station with steering of that
tiny turn, yeah. Yeah.
We still on 2.8.
Fair enough. How did you come up with that 2.8, Hugh?
We tried a number from 2.5 to about 3.2. 2.8 was just. The summer restaurant in Sydney. That's what we go for. And that's history.
Hugh, there's a story that when Arthur Bishop left Melbourne, George Roberts drove him to the airport, and there was lots of criticism of George over the handling of the HQ. And when he got to the airport, Arthur Bishop said to George that he could understand that George's design of the HQ steering because he was the worst driver he'd ever been with.
George was really interesting. Whatever his faults, he was true to his principles and so forth. he believed that a car should understeer rather than oversteer. And fair enough, there are lots of right-handing engineers who would disagree with him. But I have to say this: I was the project engineer that developed the steering that George wanted. And my main claim to fame has always been that I made the HQ understeer only half as much as George Roberts wanted it to.
Thank you, Hugh, for your anecdotes. Amazing, amazing background on practical connections to what Norm presented in his paper. So thank you, Hugh. Thank you very much.
Gentlemen, engineer, and one of the pioneers of Australian engineering.
Thank you, Hugh.
Thank you.
Thank you. Bye for now.
Bye.
Louis, did you want to chime in too with some comments or questions, Louis?
Well, I've got a question for Norm. Can you explain, can you go back to the package steering rack and explain really what's going on? Because is that a rack and pinion type steering? Or
You're talking about the Packard.
yeah, I'm really curious if you could explain how the wave system works.
This.
Yeah,
It's not
the
true.
middle one there.
It's not a true rack and pinion as we know it, that I can see. In his biography, it doesn't really talk about how that works. All it does is provide you with a photograph, but it appears as if there is a type of short rack which runs through the steering box, which creates the variable ratio effect through the wave.
Okay, thank you. Thank you. Fascinating. Absolutely fascinating.
Thanks for that, Norm. Any other comments or questions?
In Sydney.
And now I assume,
It's still, they still have an office. Well, it's really not a factory, it's an office.
but their manufacturing now would be outsourced to others internationally. Yeah.
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 They didn't have a manufacturing facility. They used, in Australia, of course, they used Kirby and Bendix. There was an English Bendix company that did the Jaguar steering. I almost got fouled up because I found a reference to Vauxhall and standard cars using a Bishop steering. But it turns out there were two people with the name Bishop developing steering. There was an Englishman, but he was much, and it was a peg and rack or something that he developed, which was pretty agricultural, started on TCMGs, and it was a bit wild and woolly, as I read.
Bendix still around?
I don't know.
Yep. Yeah, that's what I.
Yeah, Bendix started making carburetors.
Louis, another comment, Louis? No?
Sorry, I don't know that my hand is up. I should have, no, you answered my question.
I'll de-raise it.
Okay.
Done. Okay. If we could join together and thank Norm and subsequently Hugh and Louis and others for contribution. Thanks for that. Norm, did you want to just stay up here? Because we might just quickly move to our final bit. That's actually the end of our papers for the day. Amazing that we've got through. It seems like it's flown by, Norm, hasn't it? But we might just go to essentially a final. I go to the slideshow. You go and get your notes, Norm. A final sort of series of points, Norm. So I suppose on reflection, it's been an interesting half day.
We have had a diverse range of presenters.
We have.
Covered a lot of topics.
We have.
Um,
Anything from gender through to manufacturing.
Yes, some new ground has been covered.
Correct.
And I'm sure there's some things that can be built on.
Yep.
And I'd encourage the presenters to put it into a written format.
Yeah.
And
there's a number of options there. So we know that
AHA will certainly publish any papers that you can put together.
Yep.
And
SAH have a journal.
SAH have a journal. I will be submitting both my papers to SAH.
Yep.
In the hope that they'll consider them. And I'd encourage the other presenters to do the same.
Yeah, and look, I'd like to reflect on the fact we have some very interesting papers that are going forward into the future, future technologies, but also reflecting on the past and trying to bring the past into something that we can, document in a new form. And I really appreciate your teams from Coventry and Deakin coming along again and presenting the progress of that. I also think some of the stuff that Louis brought up around, the Australian condition of what happened here is sort of new colour to what we've experienced locally through our own, I suppose, lens. And maybe it's something to reflect on what he presented at the start of today. And I'd like to thank everyone really who presented today as well. Look, amazingly diverse. It's great that we had 20 to 30 people online at any one time as well. I think that shows the strength of everything that's been put forward even prior to us seeing the papers, and hopefully this is something to start a collaboration with yourselves over in the US for the future for us at AHA. But I might pass to Norm as the president of AHA for some thank yous from his perspective.
Just before I do that, is there anybody who wants to make an overall comment?
Or online, if you
Online,
want, or if you want to make a comment from online. I know Bob definitely will want to say something. So maybe we'll hand over to Bob, the president of SAH, to say something on behalf of SAH.
Thank you, Simon. We all appreciate being involved in this and look forward to next year. We have two publications. One is a bi-monthly, which is 16 to 20 pages, but we have an annual, the Automotive History Review, which is 96 pages, and that has longer and more scholarly papers in it, much like what's been presented this evening or during the day for you folks. I would encourage all of you to please consider publication in our review, also along with the AHA. John Heitman, excuse me, who Chris Lazat referred to in her presentation.
So that's
John
it there,
Heitman,
Bob.
the editor.
That's what you're talking about there, Bob. So just for everyone online, that's the review there.
Right.
Yep.
John Heitman's the editor. He's former president, and he has asked me about this, so he's very anxious to hear from you folks. The journal is he starts to put it together after the first of the year, and it's physically distributed either digitally or printed copies in May or June. So you have plenty of time. We just received the latest one, I think 2 months ago. So please keep that in mind. And if there are any questions, contact me directly or through Simon or Norm. And I'll do anything I can to help out and facilitate that.
Bob,
thank you again to all of you.
Last one.
Yeah,
for that last one, you're thinking first quarter next year is sort of where you want it, things to land.
That would be a good first quarter. Would be a good good place to aim. So
Great.
Thank you again for including us in the symposium.
Not a problem, and I'll leave it to Norm in some of his comments to respond to yourself. Also, Louis, did you have something to say as well? I saw your hand up. Maybe.
I would like to thank you guys profusely for organizing this. It's been great being a participant. I am going to ask a question of your learned group. because I think the Brits could benefit from understanding what happened to BMC and Leyland in Australia, and they may well want to participate in a future symposium like this. And I've got a specific question. After the Austin A55 Ute, did Australia produce a Farina-bodied Ute?
No. Yeah, the A60.
Yeah.
It's called an A60 here. I think the A55 was the last Ute.
Okay, because the Argentinians did produce a Ute, and I wondered if there was a Farina-bodied Ute, and I wondered if there was any relationship. But that's totally offbeat. The bottom line is this, that there's a tremendous amount that the British could learn about what you did with BMC, in the same way as we're learning what happened with Ford and Chrysler and other such entities.
I think we can take the British, American, Australian potential nexus on notice. We've actually discussed that internally as a committee, and thank you, Louis, for bringing it up. We'll certainly have a look at what might be able to happen there. Yeah, we'll have to make sure that it's not just the Pacific, then it would be Atlantic. And
we might upset a lot of the POMs, though, Louis.
There might have to be like a neutral venue negotiation that happens before we move to that. But we'll see how it goes.
Well, look, you colonials, we colonials have got to stick together, and sometimes we've got to put them in their place and make them realize that they didn't do everything right. But I mean, Craig, I forget his last name. One of your members of when I was out there, he knows everything about BMC. He would be a great person to participate.
Great, thanks, Louis. And yeah, points well made and taken from our side as well. If we don't have any other points or questions from the floor or those in the room, I'm going to hand over to Norm from our perspective to make some comments. Thanks, Norm.
On behalf of Automotive Historians Australia, I sincerely wish to thank the following. To Simon, this really today wouldn't have happened without Simon. And when we started planning this conference, Simon said, I want to step back. I've got that much on my plate. I can't do anything. If this is stepping back, Simon, thank you. A big thank you from me as president, but from the committee in general and all those that have participated in today. It's a great effort. Thank you.
Can I just respond and say I think others also stepped up, and that's the reason it was manageable. So that was people like Roger, for instance.
Now to the two unseen members here today, Cho Min and Lorena, a big thank you from me and from Simon, because we couldn't have run this conference without your expertise, particularly Cho Min, who has sat there and got this technology working, because it beyond me.
And me.
So, many thanks for your graphics and software control.
And we'll be making sure that both of them are, we'll be getting them both JB Hi-Fi vouchers so they can go and buy some technology for themselves.
And they will be recognised on any publications that flow from this.
Correct.
And to Bob for ensuring that SAH members were kept up to date. And I'm an SAH member, and so I know what you did, because I got the emails in my email box too. This symposium was an idea that has really borne fruit, and I hope we can continue this great cooperation. I look forward to seeing some Australian content in, as I said, the SAH Journal as a result of today. To Skip, I don't know whether you're still there, Skip, you didn't do much. But thanks for your support. Skip was as a member, an American member, and it was his job to sort and make a recommendation as to which American presentations we used. We only got 4 and we used all 4. So
And they were great.
Skip didn't need to do anything.
Oh, great.
To Roger for organising the refreshments that we had at Mr. Tolk down the road. Harriet and the committee for a job well done. Harriet did a bit of the conference work in the early part. And finally, to the presenters, thanks for making the effort to research, write and present today. Without your input, we wouldn't have had an event. And to the participants, thanks for joining us, and I hope you can take something away from this symposium. And just maybe you can participate with a presentation next year or sometime in the future. On behalf of Automotive Historians Australia and Society of Automotive Engineers, I bid you a good evening from Melbourne and look forward to future interaction.
And a final thank you, of course, to our terrific president, Dr. Norm Darwin. So thank you, everyone, and well done on a great presentation.